right, so let's try that in the second one. So again, it says solve the triangle. So that means find all the missing pieces. Let's label, again, if they call it ABC. So I'll just start at the top clockwise. And so this would be side C, side A, and side B. All right, you are given angle A is 39, side A is 10, and side B is 14. So this time we have two known sides and one known angle, where over here we had two known angles and one known side. So it's not always going to be the same setup, but we can't do the triangle sum theorem right now because we only know one angle. So we're going to have to start with the law of sines, and I know A, angle, and side, so I'm definitely going to set that up. And the only other piece that I know is B, so I'm going to have to use B to start. Okay, so when I plug in the known pieces, sine of 39 over 10 is to sine, oh, capital B is what we're missing this time, not the lowercase b, excuse me. We know side B is 14. All right, so this time when we do our cross multiplying, we got the 14 sine of 39 equals 10 sine of B. I cannot just divide over what is being multiplied because it's not a side length that's being multiplied, it's an angle that's missing. So this one's a little more complicated. I do want to isolate the B. I do want to divide over the 10, but it's not going to just give me my answer. That will be sine of B. I'll still have an extra step to do to actually calculate B. So when I divide over the 10, I'm going to enter this into the calculator. 14 sine of 39 divided by 10. Now, for the sake of what I'm writing, I'm going to give a rounded answer, but I'm not going to delete this from the calculator because I want to use the actual number. So I'm going to say 0.88 for writing it down is sine of B. Now think back a while back when we were doing solving for when an angle is missing. To move the trig function to the other side, you end up doing the inverse trig function. That's your opposite operation of a trig function. So to move sine to the other side, it becomes inverse sine. That's how you isolate your angle when that's what you're solving for. So then I'm going to use not this rounded 0.88. I'm not going to type that in. I'm going to copy this whole number here from the calculator. Remember, you would hit second sign to get inverse sine. And then I'm just going to go up and highlight and hit enter to copy it down. So that comes out. Copy that. Now this one is an angle. For angles, I'm going to round just to the nearest angle. I'm not going to give a decimal. So I'm going to say that angle B is approximately, and that would round to 62 degrees. Now, in the picture, I'm going to add that label. Now I can use triangle sum theorem because I've got two of the three angles. So I'm going to add 39 and 62 to 101, subtract that from 180. So angle C must be 79 degrees. So now all that's left to find is side C. Again, I'm not going to use angle B because B was just found. I'm going to use what was given, which was A. So there, plug in, angle C is 79, angle A is 39, and side A is 10. So when I cross multiply, I'm going to end up dividing the sine of 39 over to isolate the C. So it's 10 sine of 79 divided by sine of 39. And when I enter that into my calculator, I'm just going to go ahead and tell you what it comes out to. To the 100th place would be 15.61. Now, here underneath the examples, it says when. We're talking about when do you use law of sines. If you remember back in geometry, when you learned about similar triangles, improving triangle similarity, you learned side, angle, side, angle, side, angle, side, 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 all those different given pieces that could help you prove triangles similar. In oblique triangles, when you are given angle, angle, side, 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 angle, or angle, side, angle. Those are the three scenarios of the given parts that will allow you to use law of sines, because you have to know an angle and a side opposite it to be able to set up the ratio. Now, one thing to keep in mind when you were in geometry, you learned that this one did not, get a different color here, prove triangle congruence. And the way I taught when I taught geometry, my kids to remember that is because it spells a bad word backwards, so it stands out. But it does, you can use, you're not proving similarity in this, you are just using the given information to find the missing parts of the triangle. So you can use law of sines when these are the three parts given. You just need to remember the order matters. Like, so in this first example, what was given was side C, angle C, and angle A. So this was not, this one was angle, angle, side. It is not angle, side, angle, because the side is not the side between those two angles. If it was to be angle, side, angle, that would have had to be side B given instead of side C. So if you want to label that, if that helps you, this one was angle, angle, side. Okay, and in this one, you were given side A and B and angle A. So angle A is not the angle where A and B meet, so it's not side, angle, side, it's side, side, angle. Now, that is a special case when you have side, side, angle, because you could possibly have two triangles created with those given side and angle lengths measures. So with side, side, angle, you could have an acute or obtuse triangle, because sine is positive in quadrant 1 and in quadrant 2. And quadrant 1 is your acute angle, 0 to 90, and in quadrant 2 would be 90 to 180. And those could all, anything within that boundary could be an angle within a triangle. So what we solved for when we put this in the calculator and we got that angle B was 62 degrees, that would be in quadrant 1, approximately here. But the thing is, there is another angle in quadrant 2 that would give you the exact same sine value as this angle. Because remember, sine is the y when you think about the ordered pair. Okay, so this is a 62-degree reference angle. So if I found that matching reference angle in quadrant 2, I'm 62 degrees shy of 180. That's at 118 degrees. So technically this answer here that I got for angle B could have also been 118 and been true. The thing is, your calculator is not going to give you the obtuse angle. Your calculator is going to give you the acute angle answer. Okay, so that's something to keep in mind. I'll write that down. So the calculator won't give the obtuse angle. Now, what we're doing with this practice, when you're quizzed over this and everything, I'm not going to ask you for both. You're just going to use the acute angle. But you may need to know in a future math class when you're doing this that there is a possible second triangle that's also correct. This is called the ambiguous case in law of sines because it's not clear which is the correct answer because both work out. Now, if, I'll write that down, ambiguous case. Now, if we had used the 118-degree angle, if we had said that would have made this an obtuse triangle. And then when we did our triangle sum theorem, we would have gotten a different angle for C. And then when we set up that ratio, we would have gotten a different side length for C. It would have changed those three pieces of the triangle. So you have two correct answers. You could create an acute triangle from quadrant 1, or you could create an obtuse triangle from quadrant 2.